Okay, so you probably remember that Slytherins, these are going to have tails, just like snakes have tails. These are our lipids. Not only that, but they also have heads, and most lipids have a some type of head and then a fatty acid tail attached to it. So lipids are greasy, oily, or waxy. In other words, they're non-polar, the things that don't mix with water, right? Because water is like little poles, little magnets, and they mix with other things that are like little magnets. This does not mix with that all that well. So oils and waxes and greases are all nonpolar, and they generally have one or more fatty acid tail. Not all of them do, but a lot of them do. Um, so our types are these are going to be our fatty acids, our phospholipids, our waxes, and our steroids. And steroids, as you see, is actually a pretty diverse group. A lot of different things are classified as steroids. So first of all, when we're looking here, here is the head and this is the tail. So this is a hydrophobic carboxyl group. So what does that mean? Or assume hydrophilic rather, hydrophilic carboxyl group. So does that mean it's just the head? It's got a carbon in it, and OH is the carboxyl group. And it likes water. So this end, yeah, not too bad with water, but this end is the hydrophobic tail. So this end doesn't like water. So this is the part that keeps it from mixing with water, right? All right, so if you look down this chain is nice and straight up and down, right? There's all single bonds. That's what the single dashed line represents. It's all single bonds. So this one runs straight up and down. But look at this one. Same thing, same number of carbons, but some of these carbons have double bonds, and that causes the bonding angle of the tail to slightly askew to the side. All right? So whereas this one is straight up and down, this one has kinks in it, right? It kinks off to the side. Look at this one. This one's got 3 double bonds. It's kinked even further. Well, look at these last two. These are all fatty acid tails as well. This one has a double bond in it, but notice, so does this one. But what's the difference between these two? Well, it's real simple. This one, the hydrogens are on the same side, and this one, the hydrogens are on opposite sides. What does it make? How does it make a difference for the rest of the molecule, or for the molecule in general? Where this one has a kink in it, this one does not. It's straight up and down. All right, straight up and down. This is a cis fat, and this is called a trans fat. Right? Cis meaning they're on the same side, trans meaning the hydrogens are on opposite sides. Most of you know when you cook things, especially down here in the South when we fry things, man, trans fat is the way to go. Trans fat is delicious, but trans fat is very unhealthy for you. Our body can handle this. It can handle this shape and the hydrogens being on the same side. We do very poorly handling this. Right? This is the bad type of fatty acid to get. And we all know fat is flavor, right? So the more things you wrap in bacon and the more things you cook with Crisco, the more delicious it's going to take, but you're going to die a heart attack very soon with all that stuff. You don't need all that fat inside of you. This is the difference between a cis and a trans fat. And also we'll come back to this diagram here in just a minute when we start talking about saturated and unsaturated fats. So some more about fatty acids. So fatty acids generally have 1 or 2 fatty acid tails. Generally, they're all going to be either saturated or, they're all going to be straight up and down, or they're all going to have kinks in them. Triglycerides, this is a special group. This has 3 tails attached to a glycerol head. What does that mean? It means each tail can hold so much energy, so much carbon and hydrogens. This particular head can hold 3 tails, not just 2. So that's a big deal. There's a lot of energy stored, a lot more energy stored in triglycerides than there is in generalized fatty acid. So where do we see triglycerides? Well, here's some right here. This steak looks delicious, all right? But that's a lot of fat. All right, it's going to taste great, but it's going to be so greasy, and I don't, no one really cares. We're going to eat it anyway, right? Because it's delicious. Right? But this is triglyceride, lots and lots of fat. We use triglycerides in us. That's what your body fat is. Body fat is a triglyceride. It's just a more efficient way of storing those carbons. It can hold 3 tails instead of 2. So what's the difference between saturated and unsaturated fats? Right? Well, a saturated fat, remember when we talked about those double bonds versus the single bonds in the tails? A saturated fat has no double bonds in its tails. An unsaturated fat has at least 1 or more double bonds in its tails. So how does that make a difference? Well, think about this. Let me back up. Imagine this is a pencil, and you want to put it, you have a box that you want to put pencils in, okay? And all the pencils are straight up and down. There's no bends in them, right? There's no double bonds. You could pack that box full of pencils. Right? Nice and neat and orderly, everything straight up and down in rows. There wouldn't be any gaps or spaces in between any parts of the pencils. So that box would be saturated with pencils, and it's going to act like a solid because there's not any space in there, right? There's not any space between the all the pencils you've got shoved in. But let's say we take this one, right? Let's say this is a pencil, and we're going to put it in a box, and we're going to put as many pencils as we can, but all these pencils are bent. They're bent off to the side. They're not straight up and down. So when I put the next pencil in, there's going to be some gaps and spaces in between the pencils. I could fit a bunch in the box probably, but not as many as here, right? I could probably fit a lot more of the straight up and down ones in the box than I could the bent ones. It's just not as nicely organized and as neatly packed in. So we say that it's unsaturated because it's not 100% completely full. There is space around the pencils. So this one, because it's dense, is going to act like a solid at room temperature, and this one, because it's got space in it, is going to start acting like a liquid at room temperature. So butter, it's a solid at room temperature. It's a saturated fat. There are no double bonds anywhere in this. They're all straight up and down. They're packed in nice and neat and tight. There's no spaces in it. But an unsaturated fat, like olive oil, there's a lot of space in these lipids, and so it acts like a liquid. It can move around because there's space in there, so it acts like a liquid at room temperature. There's whole cultures around the planet that are based off of how much lipids you can get in your body and how much fat you get. In the Philippines, a chieftain status was known by how big his belly was. Essentially, if you can afford to eat all that fatty, rich foods and not have to work at it at all, that belly meant that. It meant, hey, I can afford all this stuff, so I got lots of money, and not only that, but I don't have to work because I'm not obviously not working off the body fat. And people would say, okay, well that's going to be our chief. He's the one who has the most physical possessions and people to work for him, and he's displaying that by his belly fat. Same thing kind of with sumo wrestlers and also football players, right? Even defensive linemen, you're not going to get a skinny guy back there, right? You want a big guy, and you want them bigger, and you want them stronger, right? Fill them full of fat, right? Get them bigger, get them more muscles, keep them heavy. That's what works well. So phospholipids. Phospholipids, this is something that we have on our cell membranes. Matter of fact, your cell membrane is made up of a phospholipid bilayer. But what's a phospholipid? It's a phosphate head that's attached with two tails. But the neat thing about it is that each tail is different. One of them is a cis. The other one, one of them is straight up and down with single bonds. One of them has at least one double bond, so the tail bends to the side. So it's got a straight one and it's got one that's bent. And usually when we find most fatty acids, they either have one or the other, but not one of each. And so phospholipids are the main component of our cell membranes. So you got a hydrophilic head. It likes water. So there's water out here on the cell membrane, and there's water down here on the cell membrane. But there's not water in between. Why? Because that's where we find our hydrophobic tails. They don't like water, so they turn. And that gives us a nice outer layer and inner layer of the membrane. And that's what helps keep water from going through your body and being lost. It helps keep random things from coming in, like viruses and bacteria. And it does all kinds of neat things for us. But that's our phospholipid bilayer. So that's a phospholipid. Waxes and steroids. Waxes are pretty easy. Essentially, waxes are just a natural water repellent that also acts as a lubricant. When we see this in some biological systems like us in between joints. We also see this in nature for things like plants. Plants have a waxy cuticle that's over them. Ever pick up a piece of fruit from the grocery store, like an apple? Rub your fingernail across it, and you'll see there's a waxy layer over it. And yeah, it adds a shine to it, makes it pretty, but it also keeps it from dehydrating. Now they have their own natural covering. Stores will actually put wax over them too to help them from dehydrating and actually make them look prettier. But all plants generally have their natural waxy coating. If you're a cactus living in a desert, you have a very thick waxy coating that covers all of your leaf pads, and that's to help you stop losing water Because if you're in a desert, there's not a whole lot of water. And if you're a plant, you can't just pick up your roots and walk down to the stream and get a drink every time you get thirsty. So that waxy coating helps. Now we know some animals, like insects, specifically bees and wasps, will use wax to build structures like honeycomb for storing their larvae while they're developing, or for storing honey. Ladies, we know you wax your legs. So guys, if you're listening and you haven't waxed your legs, you need to start trying to wax your legs, okay? Why do girls do this? Why do girls wax their leg? It's not fun. It's all about reproduction, right? They're trying to attract a mate. Guys, how many of you like women with hairy legs? The answer is probably none of you, okay? So women go through this. But this is a wax. They put it on, it solidifies, it binds to the hair. You put a piece fabric across the top of it, and it binds to it. And then you yank the fabric off and it pulls off the wax and the hair with it, and it hurts like HE double hockey sticks, right? There's a great movie back in the day, Karate Kid, where Mr. Miyagi is teaching his student discipline, and he's teaching him to wax a car. Well, why are they, and so the famous line is wax on, wax off. So why are they putting wax on a car? I mean, everybody says, well, it makes it shiny and makes it look nice. And yeah, it does, but there's a more practical reason. Well, wax is a water repellent. Cars are made of metal. If you don't wax your car, it's going to start getting degraded by rust, right? The metal will meet the air and it's going to start breaking down. So steroids are another type of lipid. They do occur in the cells, in the cell membranes, but they're very versatile. They can be changed into different molecules. Hormones are a type of cholesterol, and cholesterol is a type of steroid. Also, vitamin D from being in the sunlight is a great vitamin that we need. Those are all steroids, right? So cholesterol, which is a type of lipid, it's specific in that it doesn't have tails. This actually has 4 carbon rings and no fatty acid tails. So here's a little diagram of what they look like. For us, here's a better example of estrogen and testosterone. Here's the ring. Here's a ring, here's a ring, here's a ring. That's 4 carbon rings, but there's no tails. And same for testosterone. But if you look at the difference between estrogen and testosterone, which again, this is a steroid, which is it's actually a type of cholesterol. It's a hormone, which is a type of cholesterol, and cholesterols are a type of steroid. And steroids are a type of lipids, right? But the estrogen just really is known for making females females and for males males. Estrogen helps with, especially in humans, helps with the reproductive cycle and the menstrual cycle for females. Guys, you start producing testosterone when you hit puberty, right? And you never really stop. That's why the 96-year-old man in the hospital pinches the nurse's booty, because he's still producing testosterone. Ladies, you have estrogen for a while. It starts when you hit puberty, and that's when you start with having your periods. And it goes on for a time, but it eventually stops, right? Usually as you get older, especially in your 30s and 40s, the chances of you successfully having babies at that time starts to become lower. And it's because your body cannot handle that much physical stress of giving childbirth at that age. And so we have evolved, our species has evolved, for the females in our species, to her estrogen cuts off at some point, right? And we say that's called a process called menopause. And when the estrogen level goes down, I mean, this is a hormone, this is a drug in your body. When all of a sudden you basically start getting withdrawal symptoms, right? And I think some of us probably know some women that have gone through menopause, and boom, I mean, they're emotional ups and downs, right? But testosterone is also present in females. Estrogen is also present in males. Both genders have both of these, just in different amounts. When the estrogen goes down in a female, her testosterone level, goes higher. Why? They're almost identical. They're almost identical. And how do you know that a female has started to go and produce more testosterone? Do any of y'all know any older females? They're a little bit more aggressive and a little bit more opinionated, and maybe have some hair on their upper lip or maybe on their chin. That's from testosterone. That's what it does. That's why guys are more aggressive and usually have more facial hair. So when the system goes out of balance, nature has found a way to bring it back into balance, and it's good. And we all know that older female who's the husband's going, yes, dear. That's what it is. Welcome to nature. Welcome to being human. It's awesome. All right, so we'll continue on with proteins here in just a sec.